Hello everyone, welcome to Jet2 Mastery. In this video we are going to learn count of elements. So let me read the problem description. Given an array A of n integer, count the number of elements that have at least one element greater than itself. So you have a problem description 10 power 6. So this is your array size maximum can be 10 power 6. So your array value maximum 10 power 9. Okay. So this is our sample input and we'll get the sample output 4. So let's understand the question first. So this is our input. What you need to check? So you need to check, is there any, let's take any value. Let's read the question once again. So number of elements that have at least one element greater than itself, which means we need to find the number of elements. We need to return the number of elements. What kind of number of elements? The elements which has at least one greater than elements itself. Okay. So see, I am taking 5. Okay. I am taking 5. Is there any element greater than 5 is there? No. 3 is not greater than. Then 1 is not greater than. 2 is not greater than. 4 is not greater than. 5 is not greater than. Okay. So for the 5 we don't have any element. So our count is, so initially our count is 0, so till it is 0. Then move to next. Okay, if you move to next 3, is there any element greater than 3 in our given array? Yes, there is a two elements, right? 4 and 5 is there. So what we can, is there any element greater than itself? We need to count that is as a one element. So our count is now 1. 0 to, it will change it into 1. Then let's check with 1. Is there any element greater than? Yes, there is a lot of elements, so you can increment your count as 2. Okay. Then you are in the 2. Okay. Is there any element greater than 2? Yes, 4, 5, 3. These are all greater than, so increment your count as 3. Then you are in the 4. Is there any element greater than? Yes, 5 is there, so increment your count 4. So your final output is 4. That is we need. So what is our observation and what is our approach? In the previously we have done pair sum. Like that we can check, right? Let's choose your I is here. Okay. Then check all the elements, like you can say for the I range is 0 to I less than n, I plus plus. This is the one range. Also check for I equal to 0, I less than n, sorry j. J equal to 0, j less than n, j plus plus. Okay. We can check, right? We can check like, okay, is there any element? If array of I is greater than, sorry, is there any element? Array of j greater than array of I. Okay. If suppose is there any element, you can increment your count. That's it. Okay. Increment your count and break. I need to break from this inner loop. Then again your outer loop will pointing to here. Again it will start from this location to this location. Okay. Let me clearly understand the approach. Approach is very simple actually. See, if you place your cursor here, not cursor, okay. So I am checking for 5. Again from the entire loop for 5, I am checking every element. Is there any element greater than 5? Then I am incrementing my count. Also I am break from the inner loop. I am breaking. Then again it will start the outer loop. Then outer loop will be here. So in this case, again I am checking the entire array. Is there any element greater than? If it is greater than, count and break. Then again I am move forward to next element, next element, next element, next element. So but for in this case, what is your time complexity? Your time complexity will be order of n square. Okay. So let's look at our problem constraint. Our problem constraint is 10 power 6. Okay. Okay. If you have written the brute force solution, what is 10 power 6, right? So 10 power 6 into 10 power 6, that is 10 power 12. So our compiler won't accept 10 power 12 iterations. At max it has 10 power 8 iteration per second. So what will you do? So you need to optimize. How do you optimize? Is there anything you have observed? Let's look at. The question is very simple. We need to count at least, is there any element greater than at least itself? At least one element greater than itself. That is our question. Okay. So we know, right? At least one element should greater than itself, right? That is the target. What is my approach is, so what is my understanding and my observation is, let's take in a maximum value. What is your maximum value in this case? This is your maximum value. Also, we have a 2 maximum value, that is duplicate maximum value. Yes, you can choose. So my very simple question is there any element greater than our maximum element? Not really. Why? Because that is our maximum element. In the given array, that is our highest, at max value is our maximum value. So there is no element is greater than our maximum. But apart from our maximum, at least one element is there, right? What is that element? So that is our maximum element, right? That is our maximum element. Apart from maximum element, maximum value in our array as at least one maximum value. At least one maximum value. What is that? That is our maximum, right? Apart from our maximum value, our all array element as at least one greater element, that is nothing but our maximum element itself. This is our approach, right? If you take in 3, yes, there is a one greater element is there, that is 5. If you have taken 1, yes, 1 at least. They are asking at least one greater element, right? Yes, at least one greater element is there, that is our maximum. If you choose 2, yes, at least one greater element is there, that is our maximum. Yes, for the 4, we have at least one greater element is there, that is 5. But in this approach, see the given array. How many maximum values are there? The maximum value is 2. 5 is a maximum value, right? So first thing is you need to find the maximum value. Find maximum. Okay. The find maximum is 5. So what we can say? So we can say except 5, every element can as at least one greater element, right? But if you have chosen 5, how do you choose all the elements? I have an array size, right? I have a function called array.length. The array.length will show how many elements totally in your given array. So in totally 1, 2, 3, 4, 5, 6. 6 element is there. Okay. In the 6th element, you can say, okay, maximum element, it's not necessary and it's not prerequisite. Our maximum element should always only one element, right? Because in this given array, we have 2 maximum elements. In the 2 also, which means there is a duplicate of maximum elements. So you need to count how many duplication of your maximum element is there in your given array. Okay. In the given array, I have a 2 maximum array. That is nothing but 1, 2. Okay. So in the total length minus your duplication of maximum element, you will get 4. So apart from these 2 maximum, every elements are having greater elements. Okay, let's take another example. 1, 2, 2, 2. Okay, then 2. For this given example, see your array length is 1, 2, 3, 4, 5. Your array length is 5. But what is your maximum element? Maximum element is 2. Okay, so there is no such element greater than our maximum element. So you can, if you consider, okay, maximum element means it will be present only once. If you think like this, that is ever wrong. So because 5 minus, how many maximum elements are there? How many number of maximum elements are there? 4. So 5 minus 4, so only one element. Why? Because only one as a greater element. That is nothing but our 2. So this is our approach. So first find our max, then find count of max, then total length, total minus count of max. So this is our observation and this is our optimization. So this code, okay, let's write the code, then we'll understand the time complexity, then we'll analyze the time complexity. So write your code here. So initially we need to return our count. Okay, the count is nothing but first find the max. Int max equal to initially it is, I'm assigning the first value is our max. So for int I equal to 1, I less than a dot length, then I plus plus. If my array of I is greater than max, I can update my max equal to array of I. Yes, I found my max. Okay, I found my max. Then this code is for finding the max values. Finding max values, maximum value. Then I am writing another code is count of max. This is my count of max. So for int value of a, I have a max value. I need to check if value is equal to max. I need to count of, okay, let's have a count of max variable. Int count of max initially 0. Okay, if my value is equal to max, I need to increment my count of max. That's it. Then finally, so as per our observation, so total length minus your count of max. So return your array dot length minus your count of max. Is it? Yes. So let's run. We'll check. Yes, 4. For the given input, we need a 4 test case as post. But let's analyze the time complexity for a given snippet. Okay. So for the given snippet, so for this code, maximum will take order of n. Okay. This code also take order of n. So nothing, that's it. So you have a n plus n, that is 2n. So when you going with time complexity, the constant will be rejected. So you have a time complexity order of n. So I hope you have understood this problem, guys. I will catch up you in the next interesting problem.